So now I would like to invite Vipul Kochar to talk about unified test design. Right.
So I have this problem that I want to speak a lot, and so my half an hour and 15 more minutes was not sufficient. So I want to have more time of yours. How many of you use formal test design techniques to create test cases? How many of you are aware of formal test design techniques like boundary values and equivalence classes? Everybody? Then techniques like state transition tables or diagrams to create test cases, decision tables, use case-based tests. Then test reduction techniques like orthogonal arrays or all failures. Right? So there are a lot of techniques there. Some of the techniques can actually be very, very helpful in designing test cases for a specific type of a problem. For example, if you were to test a cell phone, what kind of technique do you think you would use to create test cases? So how do you create test cases today? You look at the requirements, look at each part of the requirement and say, okay, this can be tested in this way. But if the requirement is not complete, you have a problem. If the requirement is wrong, you have a problem. And sometimes it doesn't give you deeper understanding. Consequently, you are able to write, let's say, out of all this universe of test cases that are possible, you are able to write a small number. Is that correct? Then when you actually test the product, the moment you hit a button, a lot of ideas light up in your head. Oh, I can do this. Oh, I didn't write a test case for this, but I can actually do this. I can follow not this path, but this path. If I enter this data here, for example, after I've added a user to a list, and then I go and delete that list, what happens to that user? I go and delete that user, what happens to the list? Do the mails still get sent out to that user and so on? All these ideas, they come to your mind when you are actually testing. But not when you are writing test cases, when you are designing test cases. That's why some people don't like designing test cases, because they only give you a brief idea of some of the things that can be done. Now there are two ways to solve the problem. Discard test design altogether. Why do I need to write test cases if I can't get good test cases or I can't write all the test cases? So throw the method out, it's useless. You spend 40-50% of your total testing budget, meaning time, in writing test cases, and then in executing test cases, another 40% of time. To me, this seems very unjustified. 50% time in writing test cases, 40% time in executing test cases. And during that 40%, your test cases are going to give you only 10, 15, 20% of the bugs. So you are spending 50% of your time to get 20% of the bugs, and remaining 50% gives you 80% of the bugs. Should you do more? So that's the first argument. Throw away your test design techniques, test case writing, just do ad hoc or exploratory testing. Of course, the method has its own negatives. There is no traceability. You don't know whether you have covered everything. Your manager doesn't know whether you have tested or not. Your manager comes and says, have you done testing? And you say, yes, I have done testing. And that's all the information that the manager has, nothing more, nothing less. So then people try to come up with session-based test management and things like giving a debrief. Someday we are going to talk about those things. Second thought process says, maybe there is something wrong with the way I design test cases. Maybe there is something wrong with the test design techniques that exist. Not wrong per se, but what I mean to say is incompleteness. Maybe if I have some other test design techniques, I will be able to write more test cases. Alright? So, what I really want to talk to you about today is, in these next 3 minutes, is that we need to create new techniques. I created one technique called noun and verb technique. Some of you may have heard about it, some of you may have heard me speak about it. Maybe one day I will speak about it again. Using that technique, you can find hundreds of thousands of test cases very easily, very quickly. Right? And if you have a good support, then it will solve a lot of problems. But that it will not solve every problem. Like there are 10 different techniques. So how many of you are physics students? You studied physics? Okay, all of you. Wonderful. How many of you are aware of a name called general theory of relativity and special theory of relativity? It's basically relativity. So there is a classical mechanism and there is this relativistic mechanism. Right? But these two have not been combined together. The world is still searching for something called as a unified theory. Right? Let's apply the same pattern to testing. You have all these different test design techniques. Maybe we need one technique which can combine all of this and consequently become more than what all these individual techniques are. So if boundary values in the English partition give you 10 test cases, another technique will give you 20 test cases. When you apply all of them together in a uniform way, maybe it will give you many more test cases. So whether you write them down or not, I'm not talking about that. You can do testing without writing down the test cases. Or you can write only one-line test cases, right? Let's call that as a test idea, as Brian Malik started calling it test idea. So what's a test idea? One-line test case. Check this, check that, do this and see what happens. All those are important test cases, right? So I started work on a technique called unified test design technique when I was with Adobe. I started work on it even before, but my experiment was stopped at that point in time. So I have basics of this technique available, which is based on model-based testing. So I'm throwing words you may not hear, you may not know about these words. If you do not, write it down. Go and do a search on what do I really mean when I say model-based testing. Right. A technique which combines all these different techniques. The basis is state transitions and creating a model. But I'm not talking about state transition in the usual state transition sense for those who know the technique. The idea here is to find out what you want to test. I call that as an entity. Alright? For example, you might Notepad. Alright? Everybody has used Notepad. So let's say I am testing file open. Right? So what's the entity? Your Notepad application is one entity. File is another entity. Right? File open is something that I want to test. So what I do here is write an entity and say what inputs can be provided to this entity, what actions can be done on this entity, what outputs does it produce, how does it interact with the operating system, for example. So for example, when you save a file, it goes and calls certain APIs. When you write something, it interacts with the system by displaying what you're writing and all that. So there is all these things that you put together. Then you say output of this, does it go to another entity? So you keep looking at entities and one input will take me in this path, another input will take me in this path. This is how you interact with the system and so on. For example, when you open Microsoft Word, a file gets created in temp directory. Right? So the moment you open Microsoft Word and a file, the entity Microsoft Word interacts with operating system by creating a temporary file. Now the moment I model that relationship, now I can write lot of test cases. What if the temporary directory does not exist? What if the disk is full? And so on. So all these deep test cases, which actually result in bugs in the field. These are bugs you won't find in your lab, because in your lab you have a hard disk which is almost empty. That's your test machine, right? You ghosted it and it had nothing but the basic things. So there is terabytes of space available. But real life, the space might go up. So this kind of helps you model your entire system in terms of various entities and sub-entities and how the messages flow. So if anybody is interested in working on it, I have the base theory available. We'll develop it in terms of sequence of steps to be done, and then you can apply it to your project and see if it makes sense. Right? From that we'll learn, we'll modify the theory, right? And probably after 2 or 3 iterations, we will have a new test design technique which combines all of these and gives you something more. So anybody who's interested in contributing to it, learning about it, or applying it to their projects, feel free to write to me, vipul@puretesting.com. Right? And I look forward to interested people. I applied it to a little extent in Adobe, not on Adobe products per se, but I did some experiment with a friend of mine, Avinash Mitra. He's not here today, unfortunately. We applied it to Notepad, and we were able to find some very interesting behavioral issues in Notepad by this. Now, who would say that Notepad really has anything to any bugs to be found? We use it all the time. But there were some very interesting race conditions we were able to find in Notepad by this. So I look forward to information from you. And let's try to create a new test design technique. Similarly, you can also think, how do I write test cases? What are the weaknesses? Can I improve it? Can I create something new?